Hi everybody, welcome back from lunch. First session after lunch. I hope you had a good meal. We want to welcome you to our session, Lord of the Rules, the You Shall Not Pass of Kubernetes Networking. Before we start, some words about us. My colleague, good friend.
I'm Christoph, working as Technical Solutions Architect for Isovalent, now part of Cisco, so I'm doing Kubernetes networking with all of my customers.
Yeah, and I'm Philip, work at White Duck at Cloud Solutions Architect. I'm also Azure MVP, and normally I do everything around Kubernetes on Azure. Okay, we just start. The people are coming. So to our agenda, in our session, we want to give you a brief introduction, not about us, but to tell you some stuff, what we assume you should know. Then we talk a little bit about multi-tenancy in Kubernetes. I think it's a common pattern or topic, but I think that we are on the same level, have the same understanding. We would do that. Then we talk about Cilium policy enforcement modes. We talk about implicit versus explicit policies, and Christoph will do a demo.
If time allows.
Yeah, we will be fast. Okay. Before we start, I want to make some questions. So who is using network policies in Kubernetes? And who of you managing the platform? And who does network policies for their teams or apps running on? Okay, that's okay. Perfect. Okay, wrong button here. For our presentation on what we talk about, we assume some things. So we are running on a platform, because platform is a hot topic. The platform team has their own namespaces, always like Ingress, Nginx, monitoring stacks, whatsoever. So we assume that the platform team managing their own network policies for this slides. Yeah? The platform is multi-tenant, so every app, every service, every team has their own namespace, a proper RBAC is in place. We will also talk about that in some moments. And the app team, basically, or the teams are in charge doing their own network policies. Yeah? So we don't want to handcuff our teams and move the workload to the platform team and make network debugging and stuff like this. So we have our idea is that the separation of platform and the apps. Yeah? And Cilium is installed also. And in the typical, I think everybody knows, but like I said, that we are on the same page. We have a cluster, Kubernetes cluster. It's multi-tenant, so every app runs in a namespace. There are pods, containers, yeah. And the app team basically chooses then who is allowed to consume the apps. So they can make allow policies in their namespace. They can make deny policies. Yeah. So common pattern. Okay, and then often at the end, when our platform team is then checking the platform, we end up like this. So who knows this scenario? 2. Okay. I think you're not honest. But okay, often we end up like this. So we give out some freedom. We give freedom to the people, and they're doing like stuff because we don't have good guardrails in place. But today we talk about it. So we talk about a good network concept. Yeah? So zero trust is always for the win. We also want to pass some knowledge about Cilium enforcement modes and explicit versus implicit deny policies, the difference and when you use which. And also we talk a little bit about RBAC, or rollback access control.
Right. So first of all, we want to give you a quick refresher on Cilium Network Policy, how and where it's enforced. Generally speaking, Cilium Network Policies are enforced in kernel in eBPF. So every Kubernetes workload at the very end of the day has this small eBPF-driven firewall sitting right at the network interface of the pod. And the Cilium agents on every node, they're actually in charge of translating policies that we've sent to the Kubernetes API into eBPF code and inject it into the kernel. Right? Usually, we use all the Kubernetes-related identities like labels, namespace, to target which policy applies to which workload and which destinations are allowed to be talked to. Right? Obviously, we can also use other identities like IP addresses or FQDNs. In Cilium, there are different types of network policies. Who knows how many different types of network policy CRDs there are in Cilium? Simon, come on. Calling you out. I understood 3. I think 3 is correct. So today we're going to talk only about 2 policy types in Cilium. We're talking about the Cilium Network Policy CRD object and the Cilium Clusterwide Network Policy. There's a third one, which is called the host policies. If you're attending Container Days Hamburg, Simon will give a talk about those. So just a quick advertisement. The things that these policy types have in common is that actually you can use them both for building policies from layer 3 to layer 7. Both of them can use the same set of labels to target endpoints, to target destinations, to target sources, and both of them can also use other external identifiers, like IP addresses, like FQDNs. Internally, so Cilium internally, the eBPF code itself doesn't make a difference if it enforces a cluster-wide network policy or if it enforces a standard Cilium network policy. So they have the same priority, they have the same enforcement point in the network itself. The big difference between the 2 policy types is essentially that cluster-wide network policies, they are a non-namespaced concept, right? So you require higher privileges to apply these policies, which means that not everybody who owns a namespace is allowed to apply a policy that is cluster-wide and potentially can target all of the different other namespaces. Also, cluster-wide policies, they can be selected to be only enforced on specific nodes via node selectors, but we're not talking about this today. Is anyone in the room here using cluster-wide network policies already in their environments, besides Simon? Okay, 2 people, wow, I would have expected much more. Cool. Then, I said they have the same priority, they have the same enforcement point, which in turn means we can get the exact same outcome with a Cilium network policy and a cluster-wide network policy. So in this example on the left side, you see a, I would say, traditional namespaced Cilium network policy living in the namespace foo, targeting my backends. And on the right-hand side, you see the cluster-wide network policy that has the exact same outcome, which means they are targeting the same endpoints, they are allowing the same traffic. It's just the difference in where you actually define the namespace to be targeted, right? So as the one policy is namespaced, obviously it only lives in one namespace, but also with cluster-wide policies, you can target just a specific namespace. When it comes to RBAC, Philip will give you some examples on which RBAC you need for which type.
Yes, and we just brought a rough example how we would like to have RBAC implemented. So in this, we have like a cluster role, which is the Cilium operator. So operator editor. So this cluster role can edit Cilium policies. Yeah. So what we then do is basically like a normal cluster role binding. Role binding on on the namespace. So we have the cluster role, and we bind it to one namespace. In this example, is the default namespace, and every user which is selected by the cluster role binding, can edit then these network policies in the namespace. The same we have for the. It's not working here. Here, and this is like the one for the cluster Cilium Clusterwide policy. So we have a cluster role which is the viewer, so they can view all of the Cilium Clusterwide network policies. And here, this time, we make a cluster role binding, so they can see all the network policies which are cluster-wide in the whole cluster, but not edit them. This will be important later, but we will come to that. And the next topic we want to address is like the Cilium policy enforcement modes. Does anybody know about the enforcement modes already? 1, okay, perfect. When you install Cilium, it comes in the default mode. So the default mode is that until you specify any policy, all traffic is allowed. So when I create the first policy, as a good example is like we make a DNS policy on a pod. Yeah? So all other traffic then will be blocked. So until we select this container. Yeah? And then we have the more restrict mode. It's the always mode. And this one is like when we install Cilium with this always mode, so no traffic will be allowed. You can also see it there, we put it there. It also impacts the Cilium health checks. So we have these health checks are therefore that the node communication, the node or the Cilium agents can reach each other on the cluster. So in the always mode, everything is blocked by default. So you have to allow any traffic in the cluster, also the health checks. And then we have the never mode. We don't want to touch that because nobody should use it. So everything is disabled on the cluster. Also, if you specify policies, there will be no effect. Okay. That's your
right. As we've seen, only one person raised their hand when asking about the different enforcement modes. So we assume from now on that, as nobody knows, there are different enforcement modes. Everybody works in the default mode. So the rest of our presentation is actually based on the default mode and how you can make it secure with network policy, right? So in default mode, essentially, at the very beginning, if you bring out a new application on the cluster, every traffic is allowed, right? So if somebody wants to curl something, there's no policy in place, so traffic goes through the eBPF firewall, and it is allowed. We don't necessarily want to be that open in our clusters for our developers, right? So we want to have a bit more security. Hence, what we can do with the cluster-wide network policies is we can specify an implicit deny for all of our endpoints, right? So with what this cluster-wide network policy essentially does, it subdivides our cluster into two separate parts. We have, first of all, some namespaces that I'm running as the cluster operator, where I'm in charge, where I trust myself. I'm excluding this from this policy, and for all the rest of the namespaces, which are not listed in this list up here, they are actually being targeted by this policy, which means the default mode will switch into a default deny mode, right? So every Kubernetes endpoint will only be allowed to call kubedns in this example, right? There's no traffic that's being allowed into the pods and out of the pods. And with that, we've actually blocked this curl to the outside world. Now, if we give developers the power to build their own policies, they will not be necessarily happy with this, right? And maybe they're too lazy to build a proper policy. So there might be maybe people that actually put in a policy like this, right? So they're allowing everything in their own namespace. And with that, they can completely circumvent the implicit deny all that we've implemented with our cluster-wide network policy. So what does this tell us? This essentially tells us that even though you may be able to run in a default deny mode, this may not be enough to actually build proper security from a network perspective in your cluster. And with that, we are back to our initial problem that Philip showed us, where everybody can do whatever he wants without restrictions, even though we were starting with a default deny mode. So now the question is, how can we prevent this? Especially if you're running in a big enterprise, there may be some rules that you need to adhere to, right? Philip.
Yes, thank you. Okay, and in Cilium, we have a better option to enforce guardrails on this, and that's the explicit deny policies. Yeah? So as Chris showed, by default, in the default mode, and also in the always mode, the implicit deny is used, but we can explicitly deny policies and enforce guardrails. Yeah? And the important thing is the last sentence. So the explicit deny policies are always a higher priority than the allow rules. So when I, as a cluster admin, enforce or apply a deny policy explicit, then nobody can override this policy. That's basically the idea. And here we have brought some ideas for you. So for example, we can block internet siders. Yeah? We can say, hey, we have a test namespace. We can enforce the policy on the namespace and make explicit deny there. We can, for the whole cluster, disable SSH or telnet communications. We can, for ingress, only allow HTTPS, so network layer 4, TCP, only this. Yeah. And here's a good example. So as you see on the examples before, we use the explicit egress deny. So we here, as you brought in an example, we allow only block port 80, yeah, and we block port 22 as explicit. So nobody in the cluster now can override this policy with the allow. And here we brought also a good list for you. As you can see, in the first row, we have everything. We have allow policies on port 80 and 443, so traffic is allowed. Yeah? And then we implement a deny policy in layer 4, only so block port 80, and the traffic is denied. And at the end, if you deny everything, so layer 3 and layer 4, everything is denied at the end. I think it's a good overview that the deny is more powerful and is our Lord.
All right, cool. Now, how does this solve our problem, right? That everybody can essentially open whatever he wants as soon as he has the power to build network policy in its namespace. Essentially, the idea that we're presenting here is that if we combine cluster-wide network policies with explicit deny rule, this can be much more powerful than just running in a default implicit deny mode, right? Because as we've seen earlier, an implicit deny can always be overwritten by an explicit allow. But if we are using explicit deny, this cannot be overwritten by an explicit allow. So coming back to what we've seen before, we're running Cilium, and we're putting this implicit deny on all of our app namespaces, right? So again, if somebody wants to override it with its allow all rule, he can circumvent this. His traffic can get through. We have one example here for you how we can actually use an explicit deny to lock down those behaviors, right? There are other ways you theoretically could do it, like you could use OPA, you could use Kyverno to check every Cilium network policy that's being applied against the Kubernetes API. But we think that maybe a more elegant solution might be to use cluster-wide policies with an explicit deny rule, right? So what this policy does is actually it disallows our applications to talk to the internet directly. This is just one of the examples that Philip showed earlier. Could be like that we are explicitly denying plain HTTP, SSH, Telnet, whatsoever. But with this policy, essentially, we first of all allow deny explicitly any traffic to 0000, and then we can put in some exceptions, right? We can put in the RFC 1918 addresses, we can put in our own CIDR blocks that we trust to connect directly. But if we implement this policy, as we've learned earlier, cluster-wide network policies go into the same eBPF instance for the Kubernetes port than a traditional network policy would as well. If we apply this policy, nobody can talk directly to a public IP address, but if somebody wants to allow traffic or talk to an internal IP address, this can be allowed, right? So even though there is an explicit allow all rule, we can essentially put guardrails on our cluster so that company-wide policies, they are adhered to by the developers if they want or not. Right. With that, I'm going to show you in a live demo, if everything works out fine, how this can look like. Right? So we're working on the same example. I have a Kubernetes cluster. I have a small application running in here. Right? So it's just a single pod. You can see this one is the one that I'm executed in down there, and I have just one cluster-wide network policy, which is the exact same one that we saw earlier in the presentation as well. So I'm like excluding some namespaces where I think I'm trusting these namespaces. I'm denying everything else, and at the bottom I'm allowing DNS, which in turn means that my application here, if I'm doing a curl to the outside world, it first of all doesn't work, right? You see, I'm trying 3.2.13 something, it doesn't work. I can see it also here in my UI, where I see that my demo app is trying to talk to HTTP bin. Now, I'm the frustrated developer now. I don't want to build proper policy, hence I'm going to put this allow all policy onto my cluster. It's this one here. I'm putting this onto my cluster, and now, essentially, even though I had the implicit deny, now I have an explicit allow all for my specific namespace. I can get out to HTTP bin, as you can see, get a beautiful teacup there. But I'm talking directly to a public IP address in this example, which you can see up here. Right? Now, if I want to make sure that, for instance, I have my company-wide policy which says don't talk directly to public IP, please use an HTTP proxy for this, I can now use this cluster-wide policy with an explicit deny to, first of all, deny the connection again. So I'm overruling what my dear developer friend did, putting this cluster-wide policy on the cluster with an explicit deny, and again, my application is broken, right? If now my application people come to me, I can tell them, okay, please use a proxy instance, right? I have a proxy instance deployed as well. And if I'm now going through this like kind of security gate, this example, I can see it's working again. I'm going through my proxy. I'm not talking directly to a public IP, so I have an instance that actually can check my traffic, can make it more secure. And with that, my app is back up and running. I have my guardrails on my cluster, and we are pretty much at the end of our presentation.
You can also show that the traffic flow.
Oh, the traffic flow,
yes,
for sure. Right, so what we can see if we check, I've deployed my proxy on Kubernetes as well. And what we actually see here, sorry. Yeah. This is, thank you, PowerPoint.
We have 7 minutes, all good.
Right, yeah, I've put my proxy in here, and what we see now is that actually my application down here, my application pod is talking through my HTTP proxy to the outside world, and it's not allowed anymore to talk directly, but it still works. So.
Just an example how you could do it. You don't need to know. You can also just disallow traffic, and you're good. Okay, so our key takeaways for today is the default deny. So the implicit one is not enough because it can be always overwritten in both modes, default or always mode, Cilium. Yeah. The CCNP, the Clusterwide Network Policy, can be used to deny unwanted traffic. Yeah. And the explicit deny always tracks precedence. And yeah. And also the last one is like we need advanced privileges. So a proper RBAC concept is always key. That we have a good network security in our cluster. So that the namespace administrator, also you call it developer, the namespace owner, cannot modify this cluster-wide network policies and allow traffic and override our policies. Yeah, that's it.
Right. If you want to learn more about network policies, we do have some books on the ISO Wayland website where you can scan the code, get your free copy of the book as a PDF. We just want your personal data for this. So doesn't cost that much.
Only you, not me.
Right. And with that, we are open for questions if there are any. If you're too shy, we are also outside at the White Duck booth after the talk. There's one.
Maybe you have a mic, I don't know. Perfect.
Thank you. Really great presentation. I was wondering, when I start up with setting up network policies, can I enable them in a way that they are more like a dry run and I get insights in, hey, what are people even calling and what do I need to disable or enable to just get an overview first before enforcing it?
Yeah,
I think you can go. I don't know. Yeah. I would say my way, and then you take the professional way of. Okay, if you, as you said, you have the default mode, and then you make the first policy, for example, DNS policy. Then all other traffic is blocked, and then you see it in Hubble, for example, what you showed, that all the traffic is blocked, and then you can work from that. But maybe there's a better mode. There's the debug mode, I don't know.
There are several ways to achieve a goal with how to build proper policy in Cilium, right? So you could use the non-enforcement mode, and this will still tell you what a policy would have done to traffic if you apply the policy, but traffic will go through. There are also options where actually you can run with an allow all policy and then still see the traffic and like build policy and then remove the allow all policy. And there's a observation mode, but this is not cluster-wide. This is on a per node selection where, again, policy is not enforced, but you get the information what would have happened with the traffic. So different ways to achieve the same goal.
But I think also with the allow mode, if you select the policy, you will all see in Hubble, for example, or in Hubble CIU, you will see also the allow traffic. So from there you can work on.
There's another one.
So thinking of hyperscalers and Cilium on hyperscalers, they have their, so particularly thinking about Google now, they have their opinionated way of implementing Cilium. I was wondering what's your opinion on the way this will play out in the future?
I have no idea how this will play out in the future. The only thing that I can say is that as long as you're running data plane v1 in Google, Google still allows you to switch the CNI and to install a full-fledged Cilium. Data plane v2 is a Cilium fork, but they don't allow you to get all the features and to switch the CNI. So it's not essentially our decision, it was Google's decision to run the fork. No clue how this will end up in the future. Sorry.
Yeah, thank you. It was for a long time that I was waiting for using the Cilium in the AKS cluster from the Azure side, but it was a lot of the limitations in place. It feels like now the limitations has decreased, but still some of them. Do you have any experience in running the Cilium in the AKS and with those limitations?
So in AKS, essentially there is a mode where you can bring up the AKS cluster with CNI none, and I'm not aware of any limitations running Cilium there.
Yeah, they just say that like IP block, it is more like it's still not available. In the past, it was just say that even the hub was not available, but it feels like now it's no more in the list. That's why I thought you know how this is.
But in Azure you have several modes. You have the AKS with the managed data plane by Cilium. This is basically like a stripped down Cilium version, which has not all the features. But what he said, you can always bring your own CNI and install Cilium open source and have all the features available. And there's also another option, it's called ACNS. I think it's Advanced Container Networking Service. Yes, and there you think you can use also Cilium, but you have to pay 20 cents or €2 per node per hour to use the advanced Cilium features. So basically you have 3 options to run it.
Essentially, the cluster I was showing was on AKS.
Yes.
Okay, thank you.
But you can also come to White Duck booth, we can talk about it. Say you Azure. No.
Thank you for the talk. I have a question about writing those policies. Do I need to specify TCP and UDP, or can I combine them for a specific port?
Yeah, you can also just use the port. You don't need to explicitly state UDP or TCP, you can just say port.
Perfect.
Should work.
Should.
Anyone else?
Okay, we have 7 seconds left.
If not, you will find it outside here. So.
Right then, thanks for attending.
Thank you.